Hi guys, and welcome to episode 9.2 of the data series. It's been quite a while. I've been quite busy with exams and work, but now that they're over and done with, I'm looking forward to be uploading more frequently. In this episode, I plan to go over an implementation of a support vector machine. So here I've imported the relevant libraries. So pandas to import our data, matplot library and seaborn for any plots, numpy for linear algebra operations. I've also imported warnings here to ignore any warnings that pop up. So the first thing we need to do is to import our data. So hopefully there's going to be a link in the description as where you guys can download the data and also view the code for this episode. So here I've saved the data under the following file path. We then do pd.read_csv and then put the file path. And here I've saved the data under the variable name apples_oranges. We can then use the .head function to display the first few rows of the data. We run these two cells here. We can see that we have the weight, and in this case it's in grams, and the sizes in centimeters of different oranges and apples. So we can then produce a scatter plot of our data by using the following code. So here I create a color dictionary to map all the oranges to an orange color and all the apples to a green color. And then create a title. So here I just put sizes and weights of apples and oranges. We then use the seaborn library to produce a scatter plot. So we define the data, which is apples_oranges. On x-axis we're going to have the weight. On the y-axis we're going to have the size. This hue equals class basically says to distinguish the data points according to the class. So color oranges as one color and color apples as a different color. And we define the palette here as a color dictionary. So to color all oranges as orange and all apples as green. So if we run this cell here, we obtain our scatter plot of oranges and apples. And here our oranges are colored as orange and apples as green. So now we want to calculate a hyperplane that separates our oranges and apples, which can then be used given the size and weight of a fruit. Can classify it as either an orange or an apple, depending on whether the fruit lies below or above the hyperplane. So to build our support vector machine, we define our input data, which here is the weight and the size of the fruit. We also define our target, which in this case is the class, so either an orange or an apple. We then import SVM from the scikit-learn library, which gives us access to support vector machine algorithms. So since this is a classification problem, we use SVC, support vector classification. We set the kernel equal to linear since we want to separate our data with a straight line. This C equals 10 gives the cost. I haven't covered this in my previous episode as this is more relevant for non-linearly separable data, but essentially with a higher cost we put a bigger penalty on misclassifications. So let's say for example this orange point here was moved to be mixed with the apples. With a high cost, our hyperplane will try its best to separate the oranges from the apples. And with a lower cost, it would ignore this orange point that's been moved and destroy a hyperplane in the middle. We then fit our data to the model. So if we run this cell here, we've produced our support vector machine. To obtain the coefficients of our hyperplane, we can use the coef_ attribute, and if we run this here, obtain our coefficients. And to get our intercept or bias, we can use the intercept_ attribute. Run this here, we get a value of around 62.1. So here I've just made the intercept equal to b, the first coefficient w1 and the second coefficient w2. We just run these here and we get the values outputted here. So finally our hyperplane takes the following form. So 2 decimal places, 62.1 minus 0.66 times the weight minus 3.12 times the size equals 0. And that gives us the equation of our hyperplane that separates our data with the largest margin. To plot our hyperplane and support vector lines, you can use the following code. For plotting our hyperplane, we want to plot the above equation here, where our weight and size values produce an equation where it's equal to 0, and for our support vector lines, we want to find the weight and size values that correspond to this equation here, equaling to 1 or minus 1. So here, we produce our axes. We then produce the same scatter plot as we did before. We obtain the minimum and maximum weight values and minimum and maximum size values. And we do this because we want to create a grid of x and y values so we can find where this equals 0 for our hyperplane, so in this case, and equals 1 or minus 1 for our support vector lines. So here we create 30 equally spaced weight values between the minimum and maximum, and we also do the same for the size. We then create a mesh grid. We then stack the x and y values so that we can put them into our decision function here, and we store the output into the variable z. We then plot the contours and the levels as to where the equation is equal to -1 or 1 for our support vector lines. and 0 for our hyperplane, and we set some styling here. We can also highlight our support vectors by using the following code. So if we run this here, we can see our hyperplane and support vector lines, and also 3 support vectors. We can obtain the values of our support vectors by using this code here, and if we run this here, we see the values of our 3 support vectors. And lastly, let's now use our support vector machine to make a classification. So let's say, for example, we recorded a weight of 70 grams and a size of 4.6 centimeters. That will lie around here. So we would expect our support vector machine to classify this as an orange since it lies below the hyperplane. So we run this here, we get an output of an orange. And if we change this size, let's say move it further up to 5.7. So now it lies above the hyperplane, we'd expect a classification of an apple. And yep, we do. So thanks guys very much for watching, and I hope you learned something new. I do plan to spend more time on support vector machines as there's still a lot that I haven't covered, and perhaps I might do a data science project based on support vector classification. Thanks again for watching, and take care.